So, have you ever had this experience? You're having a chat with someone, and they're telling you something about a subject they're very interested in or they know a lot about. And you're following along, and then at some stage you realize you kind of lost the thread of what they're saying. And then you're standing there and you realize you've got absolutely no idea what they're talking about. I had this recently with a friend who knows a lot about investing. And it's something I don't know a huge amount about, but it's very important, very useful information. When he started talking about kind of diversified investment portfolio, blah. And unfortunately, I went away with no useful information. So I think it's a situation we all are familiar with. And fortunately, there's things you can do to improve this situation, which is what I'm going to talk about today. So I'm a scientist. I work in the area of quantum physics. And so I've been on both sides of this kind of interaction. I've both been the guy explaining the very complicated material to someone, but I've also been on the receiving end of lots of very kind of intense scientific discussions with my colleagues. And when this kind of breakdown of communication happens, I've noticed something interesting, which is that as a person who's stopped understanding, you feel kind of guilty about it. But if you think about it, this is completely wrong. It's the wrong way around, because at that point in time, there's literally nothing you can do to understand better. But there is something that the other person can do to help you understand by finding a better way of explaining what they're talking about. And so during my experience in science, I found that the only way to survive was to kind of have the courage to politely stop the person who is explaining, say, "I'm sorry, I don't understand what you're saying," and then try and go back and start off from where I'd lost the thread. And it does take a bit of courage to do this, because you're kind of admitting that you don't know, the subject matter. But I think that's okay, and in fact, my fears were completely unwarranted. Generally, people respect you if you care that much about, knowing the right information or care about, understanding properly. So I think we should never, ever feel bad about not knowing something, and we should never feel bad about asking questions. So I do a lot of science communication, and science really has this communication issue with it, because generally the subject matter is very complex. And you might know scientists are always complaining about how their research is being misrepresented by the media. Like, drinking wine cures cancer. It totally doesn't, by the way. But on the other hand, you can kind of understand how journalists will maybe oversimplify things or get things wrong, because to explain cutting-edge research, you kind of need a PhD in the subject beforehand. And it's not something we can expect, the media journalists to have in all the different scientific disciplines. So I think the world would be very well served by a whole load of people who are really, really good at science communication. People who understand the science, but can also explain it in a way that the general public can understand. And this is important for many reasons, but one reason is you might know that just about all the science research that goes on around the world is publicly funded. So it would be nice if the general public could actually understand the work that their money is going towards. But for me, the even more important reason that science communication is good is because it's all so interesting. The research going on is so fascinating, it would be nice if people could access it. Take my field, for example, quantum physics. I find quantum physics to be a deeply interesting subject, but it's one that gets this reputation of being incredibly difficult. And that's fair. It gets complicated when you get down into the details. But it doesn't mean you can't talk about it at all. So let me get a show of hands. So put your hand up if you don't know what quantum physics is. And if you don't feel bad about it. Raise your hand. Own your ignorance. It's totally fine. Okay, right. So quantum physics is the description of the smallest things in our universe. So if you zoom right down, smaller than cells, down to the scale of molecules, atoms, and things atoms are made of, the subatomic particles, protons, neutrons, electrons. And it describes how they all work and also how they interact with light. And the interesting thing about quantum physics is it's like the fundamental rules of the universe, and yet the things that happen there are so very strange. So I'll tell you a few of the phenomena that go on in quantum physics. One you might have heard of is called particle-wave duality. So you can imagine all these subatomic particles, these protons, neutrons, electrons, like little bouncy balls, kind of bouncing around, bouncing off each other. But sometimes you have to treat them as like spread out waves. And they kind of do both at the same time, which is hard for us to imagine. So I'll paint a picture. Imagine dropping one of these bouncy balls into like a pond of water. The ball would disappear, and then you get these ripples going out over the surface. Now imagine one of the ripples hits, say, a stick. All of the ripples on the surface disappear, and by that stick, suddenly a bouncy ball pops out again. That's kind of strange for us to think about, right? But this is the kind of behavior that goes on in the subatomic realm all the time. Another phenomena you might have heard is called quantum tunneling. So imagine I'm throwing one of these bouncy balls against a window. So it'd be like throw, bounce, catch. Throw, bounce, catch. Throw. It's gone completely through the window. It's not smashed it. It's not interacted with it at all. It's just suddenly on the other side of the window, and you can see it flying away. If we saw that, we'd think it was crazy, right? But this goes on at the subatomic realm all the time. In fact, it's the only reason we exist. So you might know that in the sun, the way it generates energy is through nuclear fusion. And nuclear fusion is when two hydrogen atoms come together, and the protons in their nucleus bounce off each other. Now, if it wasn't for quantum tunneling, they'd bounce off each other and nothing would happen. What actually happens is they quantum tunnel into each other. And that's what lets them fuse and release the sunlight. And without sunlight, we wouldn't exist. So we can thank quantum tunneling for our existence. Another phenomena is called superposition. And it's a very fancy word, but all it means is something that can do opposite things at the same time. So, for example, I can spin around one way, I can spin around the other way, but what would it look like for me to spin around in both directions at the same time? We can't do that. We can't imagine that. But this is what these subatomic particles do all the time. And in fact, we can kind of do it. At least bits of us can. So if you've ever been in an MRI machine, what an MRI machine does is it finds all of the hydrogen atoms in your body and makes them spin around in both directions at the same time in this superposition. This is what allows us to see inside people's bodies. So it's interesting that all of this physics seems so kind of abstract and remote from our everyday experience. And yet it's happening inside our bodies. We're made of quantum stuff, so it's happening everywhere around us. And it's not just MRI machines that we use like quantum physics for. There's been a whole host of other technologies that come about because of our understanding of quantum physics. So one of those is our understanding of silicon allowed us to invent the silicon chip, which is in every single computer in the world. So the entire computing infrastructure of the world exists because of our understanding of quantum physics. And it's in other things like lasers, they're quite useful, and nuclear power plants. And there's this other soundbite you might have heard about quantum physics, is that no one really understands quantum physics. Well, that's actually wrong. We do understand quantum physics very well, and you'd kind of hope that we did if it forms the technology of MRI machines or nuclear power stations. What they mean when they say that is that when we try and picture in our head something that can be both a particle and a wave at the same time, or something can spin around in two directions at the same time, we find it very hard to picture that in our heads, but we can describe it all very well using mathematics. So it's fascinating that something can be so counterintuitive on one hand, but yet can be so practically useful on the other. So I really enjoy explaining science to people. I make YouTube videos and I also write kids' books for the age range around 7 to 11-year-old. And I really like pushing myself. I don't hold back on the science. I like explaining the most complicated subjects to that age. So quantum physics, nanotechnology, relativity, rocket science, those kinds of things. And I've come to the conclusion that you can pretty much explain anything to anybody as long as you go about it in the right way. And I've come up with a set of principles I work by to do that. So I'm going to share these with you. So these are my 4 principles of good science communication. And I say science, but it can be any kind of technical communication. Okay. So number 1, start off in the right place. So everyone's got a different background. Everyone's got a different set of knowledge. And it's our job to explain the information in terms that they already understand. It's no good leaving a gap and starting from there, because they're not going to follow along. It's better to form the information from what they already understand. And how do you do this? Well, it's as simple as asking them questions about what they know, or even starting an explanation and then asking, do you already get this? Or is this making any sense? And if you're talking to an audience, you have to make your best guess. And a show of hands can be useful too. And it's always better to err on the side of caution. People generally don't mind hearing information that they already know. Okay. Principle 2. Don't go too far down the rabbit hole. People can only take on a certain amount of information at any one time. And we have to just be realistic about that. So it's better to explain, say, 3 things that someone will understand and remember, rather than barrage them with a whole load of information that kind of undoes all of your good work to begin with. So I could have carried on talking about quantum physics, but hopefully I gave you enough examples that kind of piqued your interest and you can go away with. Okay, number 3. Clarity beats accuracy. So when we're explaining things with examples, the temptation is to give the most scientifically accurate explanation. But they tend to be very long and kind of convoluted. It's better to come up with a simpler explanation that maybe isn't completely technically correct, but it gets the point across. You imagine they're here, and the complete explanation is here. All you want to do is just get them along that path. So for example, when I was talking about spin in quantum systems, the truth is actually a little bit more abstract of spin in these subatomic particles. But what I tell you is a good picture. And if people are still interested, you can always iron out the details later. Okay. Number 4, explain why you think it's cool. If you're explaining something to someone, there's a reason why you're doing it. Either you think it's super important or very, very interesting. And the more that you can convey that to someone, the more likely they are to remember it and kind of get some value from it. And you can do this in many ways. One way is just to show your enthusiasm for the subject. Another way is to show, using examples, how it's relevant to their lives. So for example, with quantum physics, every time you turn on your phone, you're invoking the fundamental laws of the universe to do your bidding as you tweet photos of your cat. So those are my 4 principles. So I'd just like to leave on an anecdote. When I meet people for the first time and I introduce myself, say I'm a physicist, I get one reaction more commonly than any other, which is like, ooh, physics. Oh, I was rubbish at physics in school. And it happens so often, it's such a shame. Science shouldn't be about whether you're good at it or not. It should only be about whether you're interested. And so if you find science intimidating, or you have found science intimidating, I just encourage you, there's so much good information out there these days. Just pick a subject that you're interested in, find some material, and then just from there, follow your curiosity. Thank you.